So what we're going to try to do is we're going to try to wrap up this chapter, which is on LTI systems. So just a quick recall of what we've done so far, right? So we said okay, there are systems, many practical systems that we come across turn out to be linear and time invariant in nature. And it's because of this linearity and time invariance that there's a certain relationship between the input and the impulse response of the system, right? And that and the output of the system. So in other words, the output of LTI systems can be written as a convolution of the input and the impulse response of the system, right? So who can remind me what the impulse response is by definition? So what is an impulse response of an LTI system? G. Masna.
Sir, the response or y of t you get when x of t is an impulse.
Okay, excellent. And this was so exactly. So the impulse response is actually the output that you get out of an LTI system when the input is a unit impulse, right? And that's what you actually had to do in the last problem of the midterm exam anyway, right? So that's an impulse response, right? And the convolution operation is here on your screen. So we say okay, y of t is equal to x of t star, and where the star represents convolution with h of t, where h of t is impulse response. And the definition is this minus infinity to infinity integral x of tau times h of t minus tau, right? So what we want to do here today is we want to study some properties of LTI system, in particular properties like memorylessness or causality. And for each one of those properties, we want to find a condition. For example, on what condition, for instance, the impulse response have to satisfy for the system to be, let's say, stable, or for the system to be unstable, or for the system to be causal, or for the system to be uncausal, and so on and so forth, right? So that's our objective for today, right? So the first property that I have for you is with the convolution operation in particular, is that of commutativity. Now, this is something you would perhaps be or should be familiar with. When we say an operator is commutative, what does that mean? So what does it mean when we say an operator is commutative? Jimaz.
So it means that order doesn't matter whether you put the first operand or the second operand before.
Excellent, excellent, right? So the order does not matter. Just like addition is commutative in the sense a plus b is exactly equal to the same as b plus a, right? Multiplication is commutative. A multiplied by b is the same as b multiplied by a. And similarly, the properties of the convolution operation is that convolution operator is that x convolved with h is exactly the same as h convolved with x. So the order does not matter. The order of the convolution does not matter. Which one is first, which one is second, that doesn't really matter. And the proof for this is something that we've actually done already, right? So, Maz, do you still have a question or?
No, sir, that was from before.
Right, right. So commutativity just means that y of t is equal to x of t convolved with h of t, which is integral from minus infinity to plus infinity, x of tau times h of t minus tau d tau. And if you recall, I mean, this is a proof that we did some time ago. So through a change of variables, we found the following. We found that y of t, so this is something we've done already, also turns out to be equal to minus infinity to infinity integral of h of tau times x of t minus tau d tau. And I could say, yeah, this is h of t convolved with x of t. And so we did this proof already through a change of variables. So what that means is okay, when you're flipping and shifting, right? Either you flip and shift h or you flip and shift x. It does not really make a difference. Either one of those two you can pick up and choose to flip or shift. Okay, so that's commutativity for you. So it doesn't matter convolve में convolution में flip किसको कर रहे हैं और flip and shift किसको कर रहे हैं और सीधा किसको रख रहे हैं, right? Now what this also means is कि if I give you an LTI system which has an input h of t, x of t, and has an impulse response h of t, and the output turns out to be equal to y of t, right? I mean, what I've derived up above, that means, yeah, this is equivalent to the saying I would have gotten exactly the same output had my input to an LTI system been h of t with an impulse response x of t. In other words, if I changed the input and the impulse response or interchange those two together, my output would have stayed the same. Right? I mean, this is an implication of this commutative operation. Okay, Ji Hamza.
So if the property of your system changes from from the impulse response to the x of t, it would have no effect on the output. So we wouldn't be able to see कि फर्क क्या पड़ा system के ऊपर, right?
For that input x.
For that input of x.
For that input x, right? This of course does not mean the following. I mean, so if you extend this idea and make and start saying कि यार a system with an impulse response h of t is exactly the same system as an impulse response x of t, that's not true. That's not what I'm saying.
So question, what exactly is an impulse response? Impulse पे आता है, एक point पे आके या फिर
So impulse response, as I said, Ahmed, is the output that you get when the input is an impulse. And that's what is meant by something called the impulse response. Okay? You have a black box, which is a system. If the input to that system is an unit impulse, then the output that I'm going to get, I'm going to call that as an impulse response of that particular system. Okay? But coming back to the point that I was making earlier, Hamza, I mean, I am sure you would agree, and I hope you would agree that what I'm saying is not that a system with impulse response h of t and a system with impulse response x of t are exactly the same. They're not the same. That's not what I'm saying. What I'm saying is, if there's a system which has an impulse response h, and for that there's an input x, the output that I get is y, it wouldn't have mattered if I considered another system with an impulse response x to which the input was that particular h, then the output would have been the same. That's what I'm saying. Okay?
I get your point.
There's a subtle difference here. Right? Go try to think about that, right? And come back to me if you have questions after the class. Okay? So this is commutativity. Commutativity actually. What happened here? All right. So the second property I have for you is the distributive property. So I would rather say that this is, let's make it simple. You say the commutative property. And then I would want to discuss distributive property. Any ideas what that means? Asad.
If we are given with the three functions, then if we convolute first and second, and after the answer with third, or either second or third, then the answer with first, the resultant will be same.
Okay, excellent. Right. So we know that there's a distributive property of the multiplication operation, right? We say that the multiplication distributes over addition. Right? Is that something you're familiar with? And which is exactly what you're, I think, saying, Asad, right? So A multiplied by brackets of B plus C is actually equal to A times B plus B times C, right? And similarly, we say that the convolution operation also distributes over addition. In other words, what this property states is that x of t convolved with h1 of t plus h2 of t, where h1 of t plus h2 of t is inside the brackets, This turns out to be equal to x of t convolved with h1 of t plus x of t convolved with h2 of t. Okay. Munim, do you have a question, or you wanted to answer?
Sir, I had a question regarding the the similarity showed in the commutative property. Can we say that the impulse response will be equivalent to whatever the system is within that black box? And अगर हम system को x of t देते हैं या impulse response को y of क्या कहते हैं x of t देते हैं, तो we'll always get y of t.
For a given x of t, तो एक कोई एक ऐसे x of t fix कर दें, तो फिर then yes.
So okay, for a given x of t,
yes.
There can be the system's equation can be equivalent to the impulse response.
Yes, interchange.
And
yes, for that given x
thus
of t,
vice versa.
Not for all.
Okay, understood.
Okay. And Asad, did you have a question? Or was this from before? Okay, thank you. Right. So this distributive property just says that x of t convolved with h1 plus h2 is equal to x of t convolved with h1 plus x of t convolved with h2. Okay? And I'm not going to do a proof for this. A proof is really simple. All you have to do is just plug in the definition, and you will find that because the integral is actually a linear operator, inside the integral is multiplication. All of those are linear, and the proof will very easily follow. Right? So I don't want to spend too much time on that. What I do want to spend time on is an implication. I mean, what does this property imply? Right? Ji Hassan, go ahead.
Sir, for one specific x of t, we have only one response, h of t. So, but in this distributive property, how are we getting h1 of t and h2 of t?
All right, excellent, right? So that's what I'm talking about here. What does this mean? That there's something called h1, and there's excellent question, Hassan. H1 kya hai or h2 kya hai? So it looks like I may not be talking about one system now, right? Because there may be system 1 and there may be system 2, right? And let's try to wrap our heads around what this equation means, right? So let me start with the right-hand side first. And I see that there's something here, which is x of t convolved with h1 of t. And then there's something here, which is x of t convolved with h2 of t. And then I'm adding the resultants up, right? So if I were to draw a block diagram for this right-hand side, what would that block diagram be? Right, Hamza, I'm going to come back to you. Let me get an answer to this first, or do you have an answer to this question? Tell me, Hamza, I'll ask you. So if you look at the right-hand side,
I think I can. Sir, maybe if we can look at it this way, कि अगर आपके पास एक block diagram है, you give it the input x of t, and the output is going to another system, and that system has the impulse response h2 of t, and then we're getting the final output.
No, that's not what it means. There's a plus sign here.
ठीक है.
There's a plus sign here.
All right, sir.
Zain?
Yes, sir. So could it be that we have a system जिसमें we have an input as x of t, और जो हमारा बीच में box है that has the summations of all the impulses from all the systems, and then we have the output y of t.
Okay. So then that would be actually the left-hand side, an interpretation of the left-hand side. Let's try to wrap our head around the right-hand side. What does it mean? Right. So I have some answers in the chat box. Essence says, are we giving two inputs? No, the input is just one. The input is just x of t, right? Hassan says we are giving the same input to two different systems and adding them together. Excellent, Hassan. What are you adding them together? Hassan, could you unmute yourself?
Sir, the output.
The output. Excellent, excellent, right? So if I were to interpret the right-hand side would be something like this. There's one input x of t, right? And this goes to an LTI system, which has an impulse response h1 of t, right? And of course, the output that I'm going to get, because the system is LTI, the output I'm going to get is x of t convolved with h1 of t. And then there's another system, which has an impulse response h2 of t, right? And the output for this system is, of course, x of t convolved with h2 of t. but the output that I'm getting overall is just the sum of these two terms. Right? And this would be my y of t. Right? So we say the y of t equals this, right? So this would be an interpretation of the right-hand side, that I have two systems in parallel which have the same input x and the outputs are actually adding up. Right? Does that make sense? Zan, do you have a question? All right. So, Ji Hamza.
So these two boxes, H1 of t and H2 of t, this is what Zen was talking about. If we can make it one black box, then it will be the same thing on the left-hand side.
Yeah, so let's talk about the left-hand side. So left-hand side, yeah, is what Zan was referring to, right? So Zan was referring to, okay, there was just one black box. And the left-hand side is, yeah, there's an input x of t, right? And what is that input to? That's input to a single system instead of this parallel combination that you see above, right? You have that input to a single system which has an impulse response equal to h1 of t plus h2 of t. तो एक ऐसा system था जिसका ये impulse response है. And the output that you're getting is y of t. Right? That should be the interpretation of the left-hand side. And the distributive property just tells you that the right-hand side equals the left-hand side. Right? So both of them are the same. Right? So the implication of this distributive property would be that if you have a combination of two systems in parallel, right, with individual impulse responses H1 and H2 such that their outputs are added up, that is equivalent to having just one system which has an impulse response equal to the sum of the two impulse responses, right? That's the implication of distributive property, right? Does that make sense?
Excuse me, sir.
Ji beta, ji Moaz.
Sir, I have a question, sir. Here you have distributed x of t to which is the input to two systems having different impulse responses. Yes. So, क्या इसका opposite भी possible है? मतलब, if can we put x1 of t and x2 of t in a system with same impulse response, तब भी distributive property hold करेगा कि नहीं करेगा?
Okay, excellent point, Moaz. You give me the answer to this, and I would say that the answer to this comes about because of the two properties that we've done so far, which are the commutative property and the distributive property. If you combine them together, I mean, you should immediately be able to infer that what you're saying is true. Okay? So let me explicitly point that out here. Combining the commutative and distributive property we can conclude that x of 1 of t plus x2 of t convolved with h of t. Maz, I think this is what you were referring to, right? This turns out equal to x1 of t convolved with h of t plus x2 of t convolved with h of t. ठीक है? इसका क्या मतलब है? इसका क्या मतलब है? अगर मैं इसको implications देखूं, इसको implication ये है, यार, if there's the left hand side is the following: my input is x1 plus x2. If I input to that system and I get for which the impulse response is h, I will have a certain output y, right? As opposed to this, so this is equivalent to the system where the input is x1 to a system which has an impulse response of h of t, and there's an input x2 which is an input to another system which has the same impulse response but is an independent, but some other system, an independent system which has the same impulse response, the same properties, right? And if I add the two outputs up, I will get the same output.
Okay. Thank you.
Excellent. By the way, I mean, you could have come to this conclusion some other way as well. I mean, because we know that is there something about the system properties that we know of from which what you see on the screen here, this particular thing, even if you did not know the distributive property, even if you did not know the commutative property, just by looking at this figure here, you would have been concluded, yeah, this must be equal to this. We ऐसी ढूंढ सकते. Excellent, Munim. This is because of linearity. Because linearity का मतलब ये है कि if I add two inputs up, the outputs, the output that I'm gonna get is actually the addition of the corresponding outputs anyway. Okay, so everything clicks together. Everything makes sense now, right? And this goes back to the jigsaw puzzle. I mean, what you learned earlier, everything you learn afterwards should be and is going to be consistent with what you know beforehand. Okay. Any questions here before I move on to the third property? जी हमजा.
जी सर, इससे ये जो आपने आखिरी बात की है सर, ये इस वजह से है क्योंकि we are looking at only LTI systems. Can I also say that this is also because convolution is an linear operator, या फिर सिर्फ systems की property की वजह से ये बात prove होती है?
नहीं, देखिए सिस्टम की properties की वजह से convolution is a linear operator.
Oh, अच्छा ठीक है.
Right, it's one consequence. I could say one is a consequence of the other, or the other way around, because everything is equivalent.
ठीक हो गया sir, thank you.
ठीक है, right. So the third property is, third property, right? Yeah. The third property I want to talk about is the associative property. Usman.
Sir, if we change the packets, so result doesn't change in associative property.
Excellent, right? So I think this is, I talked to somebody about this, maybe Hamza tha, yeah, Usman, you were there in the office hours. So this is exactly what we talked about then as well, right? So the associative property just says, and once again, I'm not going to do a proof for this because the proof is going to be very simple, which is if I convolve x of t with brackets may h1 of t convolved with h2 of t, this is going to be the same as x of t convolved with h1 of t first, and then I convolve this with h2, right? Or for that matter, this would also mean x of t convolved with, if I change the order, because I can use commutativity here, is going to be equal to h1 of t, right? So the conclusion here from the associative property is that the order of convolution does not matter. Right? Usman, do you still have a question? Okay.
No, sir, sorry.
Right. So can we try to visualize this in block diagrams? Right, just like we did with the distributive property, can we try to visualize what this associative property indicates as far as the block diagrams are concerned? What do you think? Who's going to help me? Nobody? Ji Hassan.
Sir, the left-hand side would be a large block which will have h1 of t convolved with h2 of t, and the input will be x of t.
Excellent, Hassan. So by the way, I mean, I say Kiji, there are points for CP, and we're gonna upload or provide you with your progress so far, किसको कितने points मिले, and some rules as well. But for your participation to be counted, your answers do not have to be correct. You just have to have an answer. Okay? But I'm very happy that अभी तक जो answer कर रहे हैं, they're excellent answers, right? So as you said, Hassan, this is what the left-hand side represents. Okay. Now, what about the other two equations that I have on the right-hand side? Ji Vita Munim, go ahead.
Sir, X of t will first convolve with, will go into a box and convolve with H1.
Good.
And then that output will convolve with H2.
Excellent. And I'm going to get the same output, no matter what the input was, right? And if I look at the third equation, that just means I'm going to give you the answer here. This is H2 of t. I can have it first. I will have it first, right? And the output then goes into a box, which has an impulse response H1. And the output is going to be Y of t, right? And all these three are equivalent, right? So they're equivalent configurations. Yeah, equivalent block diagrams. Okay, so what that means in practical sense is if you have LTI boxes, right, which are actually in series, right, which are placed in series, the order of that serial combination or serial connection does not matter. I mean, if you have H1 first and then H2, or you have H2 first and then H1, the equivalent output that you're going to get end to end or at the end is going to remain the same, right? And it's going to remain the same, and it's also going to be equivalent to the case where you just had one box whose impulse response turns out to be equal to H1 convolved with H2. Okay, so that's what the associative property means. Ji Hamza.
सर ऐसा हो सकता है कि H1 of t convoluted with H2 of t एक और H of t बनाए और फिर हम उसको convolute करें.
Excellent. So that's what the first line or figure number A represents. What you just said.
सर इनका मतलब convolution एक और H of t form करेगा ना जिसके जो फिर.
Exactly. So what diagram number A represents?
H3 of t.
H3 of t, right? So what diagram A represents, there is just one system, और उस system का impulse response क्या है? उस system का impulse response is actually equal to the convolution of H1 and H2. That's the third system, if you will.
ठीक है सर.
ठीक है? That would be equal to saying यार H1 and H2 I connect them in series together.
सही सर.
Right? So this is the associative property.
Excuse me, sir.
Yes, then.
Sir, I had a question. Sir, जो हमने properties पढ़ी हुई हैं systems की, for example, stability, time invariance, and के bounded है कि नहीं है?
Yeah.
Sir, so if we say, do they apply to these properties? Like if x of t and h1 of t is bounded, and x of t and h2 of t is also bounded, then sum would also be bounded. तो ये properties apply होती हैं?
बिल्कुल होती हैं, क्यों नहीं होती? And that's what I'm talking about next. Right. So the next three properties are going to answer your question then. Okay? Systems with and without memory. Right.
In outputs depend upon past inputs to memory if outputs do not depend upon past inputs, then memoryless.
No, it also has to include the future, right? So when we say a system is without memory, when the output at any particular time t depends only on the input at that time t, neither on the inputs of the past nor on the inputs of the future, just the input at the present time. And if that condition is satisfied, then we say the system is without memory or memoryless. Otherwise, the system is said to be with memory. Now, the question we want to answer here is, we are just dealing with a subclass of systems which are LTI systems. Remember, systems being memoryless or with memory is a general property of all systems, whether they be LTI or not be LTI. But since we're now focusing our attention on LTI systems in particular, and we know that LTI systems are completely characterized by their impulse responses. So what we want to figure out is, if an LTI system is memoryless, what particular condition does the impulse response satisfy? Or in other words, if we just look at the impulse response, can we determine what condition does the impulse response have to satisfy for the system to be memoryless or for that system to be with memory? Okay? All right. Anybody has any idea what the answer to this is going to be? I mean, it's okay if you don't know the answer. Can anybody try to think about it? I mean, just let's try to brainstorm.
Yes, sir. Sir, in my opinion, sir, can I?
Yeah, please go ahead. मुझे उस्मान ने हाथ खड़ा किया हुआ पहले, so Usman, please go ahead.
Sir, I guess if h of t is equal to 0, so जो t है वो 0 नहीं होना चाहिए.
Okay, but h of t equals 0 or t 0 नहीं होना चाहिए. So you're almost there, but I just want you to rephrase what you're saying. What do you mean by that?
Sir, if h of t is equal to 0, so it doesn't mean that t is also equal to 0, I guess.
Okay. Let's see. Zain, you wanted to say something?
Yes, sir. I wanted to add that if for the two systems that are actually being added together, अगर उनमें से कोई एक भी memory वाला है, तो फिर जो उनका summation होगी वो भी memory वाली होगी.
But I'm looking for some other answer. I'm looking for a condition on the impulse response, right? Ahmed, you raise your hand.
What does it mean to be? How do you show which systems have memory?
Yes, I mean the question we're asking is, just by looking at the impulse response, would
Yes,
you be
sir.
able to determine whether the system is with memory or without memory? Masna?
Sir, I think h of t does not depend on t. It remains the same because it's memoryless.
Okay.
Sir, random thing, but sir, अगर हम लोग उन दोनों को functions को देखें, and if they are not cancelling each other, तो फिर हम लोग बता सकते हैं, guess, like if that makes any sense.
You see, I mean, so in order to answer this question, you need to go back to the basics, right? And the basics is, I mean, what does the convolution operation tell you, right? So the convolution just tells you that y of t is equal to the convolution between x and h, right? So this is h of tau, x of t minus tau, right? If I just look at this expression, is there a contribution in y of t because of inputs of x in the future? Just by looking at because of this integral? Of course there is. Because this involves x of t minus tau, right? So for all positive values of tau, that means सारा का सारा past मैं wait कर रहा हूँ. For all negative values of tau, I'm waiting the future, right? So, but what I want is for the system to be with memory. I want here इसमें there should only be a contribution because of what? So I would say, hold on. So for the system to be memoryless, there should be a contribution only by x of t. Nothing in the future of x, nothing in the past of x, right? So when is this condition satisfied? This can only be satisfied, this is satisfied if and only if, what form would h of t take? H of t is of this form. H of t equals k, some constant times delta of t. Like that's only when this condition is going to be satisfied. So if h of t equals k times delta t, in other words, h of t must be equal to 0 for all time t except at t equals 0. Right? Except for t equals 0. Right? Because for t, when we did that interpretation or physical interpretation or intuitive interpretation of what convolution represents, I mean, we sort of alluded to this already. कि h of t की जो positive values time है वो उसके past को wait करती हैं, जो negative time पे h की values है वो future को wait करती हैं, right? And therefore, that means t equals 0 is the present, is the weighting of the present, right? And this condition therefore holds. Okay, a system is memoryless if and only if this condition is satisfied, right? So we say that the system is memoryless if and only if h of t is equal to some constant times delta of t. Okay? And let's try to make sense of this. I mean, let's just do a verification, if you will. I mean, let's do this convolution, right? So if I say that y of t is equal to x of t convolved with h of t, but h of t is k times delta of t, right? So this is integral minus infinity to plus infinity, x of tau, h of t minus tau, d tau, right? And therefore this is minus infinity to plus infinity, x of tau, k times delta t minus tau times d tau. And what does this integral evaluate to? Just using the sampling properties of the delta function, we will know immediately, yeah, this must be equal to k times delta of t, and k times x of t. And indeed, the system is memoryless. Okay? Any questions here? Yes, sir.
Sir, ये ऊपर we said कि for the system to be memoryless, y of t should only be dependent on x of t minus tau, right?
Not on tau, right? It should only be dependent on x of t.
Sir, लेकिन h of tau 1 ही होना चाहिए.
H of tau अगर 1 होता है, तो फिर what would happen? I mean, this would, if h of tau was equal to 1, right? So then you would have had minus infinity to plus infinity, x of t minus tau, d tau, right? If h of tau equals 1, right? This would have been y of t. Is there a dependency of y of t on x of t in the future and the past? And of course there is. I mean, this is integral all the way from minus infinity to plus infinity. इसका मतलब सारी की सारी past values, सारी की सारी future values, वो मिलके y of t बनाती है.
So how did you come up with the k into delta t wali term?
So that is just once again based on the visualization of what convolution represents, right? So when we looked at the physical interpretation of what convolution was, right? We said कि वो क्या होता है? So this is x of t minus tau. We see this is x of t minus tau, right? And which is being weighted by h of tau, right? So इसका मतलब h of t minus 1 is being weighted by h of 1 and then adding up because of this convolution. H of t minus 2 is being weighted by h of 2 and so on and so forth, right? But I don't want those contributions in y of t, right? All of those contributions in y of t should be 0. And the only way they can be 0 is if h of 1 was 0 and h of 2 was 0 and h of 3 was 0, right? All of the h's must be 0 except the one residing at tau equals 0. Okay? And that must be some delta. Okay? So
thank you, sir. Makes sense.
ठीक है, इसके बारे में थोड़ा सा मज़ीद सोचें, and I mean this would require a lot more thinking on your part. I mean just think about it, brainstorm, and then come back to me and we can have discussions again. Okay? जी हमजा राशिद.
सर हमने पढ़ा था कि इंटीग्रल ऑपरेटर एक समेशन है, तो सर इसमें नेगेटिव इन्फिनिटी से पॉजिटिव इन्फिनिटी तक एड अप हो रही है वैल्यूज, तो सर वो किसी भी इस तरह से वो मेमोरी ही होगी उसमें हमेशा.
हाँ, लेकिन देखिए एग्जैक्टली मेमोरी ही होगी, लेकिन अगर मैं कहूँ कि जिस चीज से मैं मल्टीप्लाई कर दूं, सारी पास्ट की वैल्यूज को मैं 0 से मल्टीप्लाई कर दूं, तो फिर इसका मतलब इसका मतलब ये है कि पास्ट की कंट्रीब्यूशन कोई नहीं आएगी, राइट? अगर मैं इसको 0 से मल्टीप्लाई कर दूं.
ठीक है, तो सर तो फिर तो आउटपुट भी हमारा 0 ही होगा.
हाँ एग्जैक्टली, लेकिन और मैं इसी तरह फ्यूचर की सारी वैल्यूज को 0 से मल्टीप्लाई कर दूं, तब भी कुछ नहीं होगा, राइट? तब भी फ्यूचर वाली की वैल्यू का कंट्रीब्यूशन नहीं होगा. सिर्फ प्रेजेंट की वैल्यू को किसी चीज से मल्टीप्लाई कर दूं, सो दैट इट शोज अप इन द आउटपुट.
ठीक है सर,
ठीक है. और प्रेजेंट की वैल्यू कौन सी है, टाउ इक्वल 0 पे रिजाइड करती है,
ठीक है सर,
right?
चाहिए।
And so h of 0 must not be 0, all others should be equal to 0. Does that make sense, Hamza?
जी जी सर।
Right, but that's an excellent point here. Acha. So from what we conclude here is, by the way, and I know, for example, I know that you've done this in system circuits as well, by the way, which is the delta function is sort of the identity as far as convolution is concerned. Okay, so I know that multiplication के लिए identity क्या होती है? What is the identity for multiplication? That's 1, right? Because if I multiply anything with 1, I get that thing itself. What is the identity for addition? Addition के लिए the identity is 0, because if I add anything to 0, I get the thing back itself, right? As far as the convolution operation is concerned, the identity is a unit impulse, because anything convolved with a unit impulse is that thing itself, as we verified. Okay? So one of the conclusions here is that delta of t is the identity for convolution operation. Right? In other words, what that means is that x of t convolved with delta of t must be equal to x of t. Okay? Now here's the question. What about the following? Y of t equals x of t convolved with delta t minus t naught. What would this be? Right?
So x of tau?
No, x of tau. What do you mean by x of
Sorry,
tau?
sir. Sorry, so x of t naught. So
X of t naught.
X of t naught. X of t naught.
Sorry,
This
sir.
is x
Sorry,
of
sir.
t naught. Right? Now you can go about this by plugging in the definition of the convolution operation and applying the sampling property of the unit impulse. That's one way you should do it, and you should go ahead and do it. The other one is just because of the fact that the system is time invariant. So if there's or convolution में क्या होता है? Convolution में I can switch it around. So if any one of those two signals shifts by a quantity t naught, the output must also shift by. So actually, this is not x of t naught by. Sorry, this is x of t minus t naught. Okay, so the delta t minus t naught, if you convolve anything with that just results in that input being shifted by t naught seconds. Okay. All right. Here's the fifth property, which is causality. Now I want to go back to Hamza, Rashid. Right? I mean, you seem to get exactly why. I mean, t equals 0 पे वो होना चाहिए, because t equals 0 is the present, right?
जी सर।
Causal systems क्या होते हैं?
सर जो फ्यूचर पे डिपेंड ना करते हो।
नहीं करते हो, right? Excellent, right? So this would be x of t minus tau. Let me write this out. H of tau, x of t minus tau. And as you said कि इस इंटीग्रल के अंदर तो फ्यूचर की भी वैल्यू सारी की सारी शामिल है और पास्ट की भी सारी की सारी वैल्यू शामिल है. But I want to somehow see कि जी how can I get rid of the contributions because of the future values of x?
सर आप इंटेग्रली ऐसा लो जो टॉट मतलब प्रेजेंट तक हो.
But integral I cannot change, right? The definition of the integral has the integral must be from minus infinity to plus infinity. But perhaps there's something I can do with h so that the integral is only in the past and not the future. Ji Ibrahim?
Sir, I think integral h of tau should be equal to u of minus tau, inverted unit step.
Okay. If h of tau equals u of minus tau, let's try that hypothesis, Ibrahim's hypothesis, which is okay. So hypothesis wait, or I can say this is Ibrahim's hypothesis, right? Which is let h of t equals u of minus t, right? So then y of t would be what? Y of t would be minus infinity to plus infinity u of minus t x of t minus tau, right? What does this evaluate to? This in Ibrahim, aap hi rahe mere sath. So u of minus t is equal to 1 only for negative values of t, right?
Ji, sir.
So therefore this integral would be from minus infinity to 0 and x of t minus tau d tau. Okay?
Ji, sir, ऐसे ही.
So अब ये x की future values y के अंदर contribute कर रही हैं या past values y के अंदर contribute कर रही हैं? Right? Tau is only negative, can only take on negative values, right?
जी, sir.
And what is t minus a negative number?
तो सर पॉजिटिव हो जाएगा ना, तो फिर
Positive
पास्ट
हो
पे ही
जाएगा।
नहीं कर रहा हूँ.
तो t इसका मतलब actually x of t plus something आएगा, right?
जी,
That integral. But isn't that the future?
हाँ सही. जी सर, फ्यूचर
I
ही.
want to only get the past, right? I only wanted to get the past, but not the future. Future नहीं होना चाहिए था, right? So this hypothesis is something wrong.
Excuse me, sir.
जी.
जी सर, मैंने ये पूछने के सर अब आपने कहा कि ये फ्यूचर पे डिपेंड कर रहा है, लेकिन सर अगर मैं फॉर एग्जांपल इफ आई गिव इट अ वैल्यू कि अगर मैं लाइक टी ऑफ माइनस 150 पे देख रहा हूँ, तो सर जब मैं इसको फ्यूचर की बात करता हूँ तो सर वो फ्यूचर 0 से आगे तो नहीं होगा ना, वो विद रिस्पेक्ट टू 150 आगे होगा, तो टेक्निकली तो ये सारा सब पास्ट ही नहीं हो जाता आपका?
नहीं, लेकिन आप what is the definition of causality? Causality कि the output at any time t, कोई एक time t, should not depend on the input which is going to come in the future from this point, in reference to this point.
ठीक है, तो जब भी आप इंडिविजुअल कोई भी
y of 150, for example, y of 150 should not depend on x of 151 or x of 152 or anything which is greater than 150.
All right, sir. ठीक है, sir.
ठीक है? अच्छा, Ibrahim, if from here we conclude कि यार this is only dependent on the future, तो फिर I mean, how would you modify your hypothesis perhaps? Essen?
Sir, I think u of tau है ना, सिर्फ u of tau होगा फिर inverted.
All right, excellent. Right, so Essen's hypothesis here is that h of t must be equal to u of t, and from here if I just do that convolution, I would find, and that's an excellent answer, right? So this would be u of t. Okay, so what we've been able to figure out is that an incorrect answer actually leads to something which is correct, right? So which is galat hoti hai, so that's not in vain, right? That helps you in finding the right path, right? So this is going to be from 0 to infinity, x of t minus tau and d tau, and this is a guarantee कि अब जो है the only values that y of x that will be contributing to y would be those that are in the past or the current time, okay, but nothing in the future, right? So this impulse response, which is h of t equals u of t, therefore corresponds to a causal system, because this makes sure that the output at any particular time t only depends on the input of the past. Okay? But here's the question, is this the only impulse response that satisfies this property? Ji Hassan.
Sir, I was thinking that why can't we have h of tau plus t multiplied with x of tau d tau inside the integral? Would it be the same thing? It will be causal, right?
Right, h of t plus tau?
Yeah.
What do you mean by that? So I'm starting with that definition, which is this definition. I'm sticking to this definition for now.
Yes, sir.
आप कह रहे हैं वो दूसरी definition कि I have x of tau and h of t minus tau. Is that what you're saying?
Sir, I'm saying we can modify this original definition by having h of tau plus t multiplied by x of tau d tau.
Okay, so Hassan, I mean, it's not up to us to modify the definition, because this definition has come about because of very, very sound mathematical reasoning based on some physics, based on the properties of the system. This is not subject to our own interpretations. I mean, this is what it is. But okay, जब आप जो कह रहे हैं, that would not be convolution anymore. I mean, that would be something else.
Yeah.
ठीक है? अच्छा. So the question I raised was कि h of t equals u of t. Yes, it corresponds to a causal system. But is this the only system which is causal? And Essen, you have the right answer. Yes, and go ahead.
So I think there should be more, but I can't think of any right now.
Right, so there should be more. And as the answer is yes. What about u of t minus 2? And if it's u of t minus 2, right? So I would say, okay, another hypothesis is h of t equals u of t minus 2. And here y of t you're going to see turns out to be equal to u of t tau minus 2 times x of t minus tau d tau. And this integral therefore goes from 2 to infinity of x of t minus tau. It's still the past. It's still the past. Right? But now can somebody step up and give me an if and only if kind of a thing? I mean, does it have to be, by the way, does it have to be u of t? Okay, Ibrahim says u of t minus k for k is greater than 0 would work. Excellent, that will work. But why just stick with u of t? Why not e raised to the power 2t times u of t? That will still work. Okay, anything I multiplied by u of t, as long as that h of t is only non-zero for positive time and it stays 0 for negative time tau, that will ensure that the system stays causal. Get the point? Right? So if I think about this a little bit more, right, and based on all of this hypothesis, what I can conclude here is, okay, so a system is causal if and only if, so that means this incorporates everything. If h of t equals 0 for t is less than 0, right? I don't care what it is for t is greater than 0. Like jo marzi ho, t is greater than 0. Whether that be a unit step, whether that be an exponential, or whether that be a cosine, I don't care. All I need is it must be equal to 0 for t is less than 0. And that would ensure that the integral here only goes from, I mean, does not go over any negative values of time, and it does not integrate over the future values of x. Okay, does that make sense? Right? So the conclusion here is a system, an LTI system is causal if and only if. If and only if the impulse response is equal to 0 for time t is less than 0. Okay? All right. So any questions here before I move on? Okay, so there's a sixth property, and that is about stability. Now, for this, I will not do a proof. I'm just going to give you a fact and take it as a fact. I mean, take my word for it. And we say again, an LTI system is stable. And the proof, by the way, is there in the book. If and only if the integral minus infinity to infinity h of t dt, the absolute value of h of t is less than infinity. Right? So if this condition is satisfied, that if I take the absolute value of h and if I integrate from minus infinity to plus infinity, if that area under the curve turns out to be finite, then the system, the LTI system must be stable. And that's the only way it's going to be stable. Agar ye nahi condition satisfy thi, then it must mean it's an unstable system, right? So you don't need to do all of those tests or some that we've defined earlier for general systems. For an LTI system, all you need to do is just look at the impulse response, and for that impulse response, compute this integral, right? Compute the integral under the absolute value of that impulse response. If that turns out to be finite, that the system must be stable. Otherwise, it's an unstable system, right? And if this condition is satisfied, right? So if this condition is satisfied, we say, so that's a definition that we have, that the impulse response h of t is something called absolutely integrable. Right? So that's something we come up with, some jargon that we come up with. Okay? So that's when the system is going to be stable. Right? So let me put a question to you. So let h of t, so consider an LTI system which has an impulse response equal to u of t. Right? चलो इस तरह कह देते हैं e raised to power minus 2t times h of t, u of t. And the questions are, is this system memoryless? Right? So who's going to answer this? Is this system memoryless? We know the impulse response. The impulse response is a decaying exponential. And by the way, this is the impulse response of RC circuits. Right? So first order resistant capacitance. Series में लगा दें, तो उसकी जो output है, that's a memoryless system. So Mahanur says this is a memoryless system. Is that what you're saying, Mahanur?
Sir, I'm saying it wouldn't store it's a memoryless system, basically.
Okay, so what condition, we just did this. I mean, when is an LTI system memoryless? What condition does it have to be satisfied? Ibrahim?
Sir, h of t should be equal to k delta of t.
Right, should be a delta function, right? And we clearly see it's not a delta function, okay? So it's not a memoryless system, right? So the other question is this system causal? So is this system causal or not? Yes, Daniel, why is it causal? So Daniel, everybody's saying causal. So Daniel, I'm going to come to you. Daniel, why is it causal?
Sir, 0 से पहले h of t की value 0 है.
Excellent.
Step 2.
Right. Is this system stable? Okay, Mustafa says yes. There are other people who say no. So let me, Saad Raza, you say no. Why do you say that? Right. So Mustafa, you say the integral is less than infinity. But what does that mean that the system is stable? Mustafa, unmute कर सकते हैं? Can you talk to me?
Yes, sir.
So maybe I'm confusing different people here. Mike has a problem. Okay. So Saad Raza says the integral keeps on going. Saad, आप जी unmute कर लें अपने आप को. Okay, Saad का mic नहीं काम कर रहा. Okay, so Manur, can you unmute yourself?
Yes, sir.
Ji, so you change your opinion now, right?
Yes.
So your opinion now is that?
It is stable because 0 to infinity हो जाएगा, and when we take the integral to minus infinity बन जाएगा.
Right, so I just compute this area under the absolute value, and this is e to the minus 2t u of t, the absolute. But since this is always positive, the absolute doesn't make a difference. But since this is u of t, this is integral from 0 to infinity e raised to minus 2t dt, and of course this is finite, right? Because it's a decaying exponential. It's a decaying exponential. The area is going to be finite, and you can actually evaluate what the area is. This is half e raised to minus 2t, and the integral goes from 0 to infinity, and this is half. Okay, and therefore the system is stable, right? So the answer is yes. Okay. Now we do have how many? About 13 minutes left. So let me do just one example that tries to couple everything together. I mean, whatever we've done, right, into a single example, an exercise, right? Okay. So here's the problem statement, right? So you're given x of t, and that x of t is equal to t times u of t minus u of t minus 1, right? Something which looks similar to the midterm problem, right? So sketch karna tha, if I remember correctly. So this is x of t equals t times u of t minus 1. My impulse response of the system is u of t minus u of t minus 1. Wait, this is 2. Okay, right. So this is the impulse response. Okay. Now, let's just quickly go over the properties of this. When you just look at the impulse response of the system, which is u of t minus 1, right? Or let's okay. Is this system memoryless? Is this system memoryless? No, right? Because it's not does not take a form of a delta function. Is this system causal? Is the system causal? Hassan says no to this, or acha. The system, yes, it's causal because it is equal to 0 for all time t is less than 0, right? So if I were to sketch this out, right, this h of t would look like a rectangular function, right? So this is like this, and this is 0, and this is 1. This is what h of t is, right? Is the system stable? The system is stable. Why? Because if I compute the area under the curve of the absolute value of the impulse response, I get a finite value, right? So the system is with memory, the system is causal, and the system is stable as well, right? Now, the problem statement was not this, by the way. The problem statement is compute the output for this particular input. Now, there's a direct way you can do it, and which would be, okay, you just consider this h of t like this, and x of t would be what? X of t, if I were to sketch this out, x of t would be a ramp, right? So it would be 0 here, and this is 0, and this is 2, right? So this would be x of t, right? One way I could do this is just use this flip and shift that dividing into cases that we've already done. But what I want to do here is to use the distributive property and some commutative property to illustrate here. That's also one of the ways you could do it, right? So what we want to compute is y of t is x of t convolved with h of t. And therefore, this is x of t convolved with u of t minus u of t minus 1. Right? By just applying the distributive property, this just says that this is x of t convolved with u of t minus x of t convolved with u of t minus 1. Right? Let me just say that this is y1 of t, and let me just say this is y2 of t. Okay? Let's just compute y1 and y2 separately. Right? So y1 is actually equal to x of t convolved with u of t. Now let's do this convolution together, right? So how do we do this convolution? Right? So I would perhaps use this, which is minus infinity to infinity, x of tau, h of t minus tau, right? Or this is actually u of t minus tau. Okay, so how do I compute this and break it down into cases? Can somebody try to identify? Okay, kya karna hai? Who's going to help me? So this is tau. Any volunteers? Any volunteers how I can, all right, Hassan? Excellent. So Hamza, go ahead.
So the lower limit for the integral will change from minus infinity to tau.
Right. So this would be x of tau, right? And what
Yes,
would
sir.
be u of t minus tau? Now u of t minus tau is just a flipped and shifted version of the unit step, right? So this is u of t minus tau for the case when t is less than 0. Right? If I multiply them together, right, as Hassan rightly points out, I would have no overlap. And when I integrate it, the answer is going to be 0. Right? So therefore, y of t for t is less than 0 is equal to 0 for t is less than 0. Actually, y1 of t. Okay. Now, what about case 2? So can I ask Hassan or maybe somebody else? Case 2 is, of course, what is that case? T is between.
So जब t 0
कौन बोला था? Please go ahead.
So जब t 0 से बड़ा होगा और 1 से कम होगा.
Okay, so good. 1 से बड़ा होगा?
0 से बड़ा होगा सर.
0 से बड़ा होगा और 2 से छोटा होगा. Right, so case 2 would be if this was tau, right? And once again, this is what x of tau was. This was x of tau. And this is u of t minus tau, where this was t, which was between 0 and 2. 0 and 2, right? So 0 is less than t is less than 2, as and many people point out in the chart window as well, right? So, and what would y of t be? Y1 of t be here? This integral would be from 0 to t. And what would I integrate? Excellent, Daniel. Integral of tau, right? Excellent. Right, and this is t squared by 2. Okay. Now, what about case 3? Case 3 is when t is greater than 2, right? And let me take the liberty of not sketching it out. I'll leave that up to you. So this would be integral from where to where? 0 to 2. Tau, d tau. And this would be equal to tau squared by 2, 0 to 2. And this is just equal to 2. Okay. So what we figure, what we conclude is that y1 of t, so that y1 of t turns out to be equal to this piecewise function, where this is equal to 0 for all values of t which is less than 0, and is equal to t squared by 2 for all values of t which are between 0 and 2, and is equal to 2 for all values of t which are greater than 2. Right? And just recall that y1 of t was actually equal to x of t convolved with u of t. Right? U of t. Achha. What was y2 of t? Y2 of t was x of t convolved with u of t minus 1. Now I could go through all of this exercise again and do whatever I did earlier, but there's a property that I could simply employ. And so that I don't have to do the convolution again. I mean, the result that you see in y1, I mean, I can use that directly to conclude what y2 would be, right? Can anybody help me here? What would y2 be? Same, Daniel, why the same?
सर क्योंकि वो सिर्फ मतलब स्टेप फंक्शन है ना, थोड़ा सा आगे हुआ है, थोड़ा एरिया तो सेम रहेगा उसका,
लेकिन आगे होने से फिर इसका कुछ ना कुछ फर्क पड़ना चाहिए, राइट? इब्राहिम?
सर आई थिंक कि वो y2 of t 0 होगा for t less than 1.
Okay.
और बाकी इसके अलावा सब सेम होगा आई थिंक. और
और
जो
इसके
दूसरी
ऊपर?
हमारी दूसरा जो हमारा वो है t 1 और 2 के दरमियान में होगा t square by 2.
All right. Okay. You're almost there, but can you try to utilize some properties that we've done? Right? You see, y1 is what you get when, so if u of t was the input to an LTI system. Okay, Masna, can you unmute yourself?
Yes, sir.
Ji beta, go ahead.
सर लोअर लिमिट्स 1 से शिफ्ट कर देंगे अब, क्योंकि हमने u ऑफ t खाली है तो वो 0 से स्टार्ट हो रहा है, u ऑफ t माइनस 1 इज स्टार्टिंग फ्रॉम 1.
Yeah.
तो इस वजह से निचली सारी लिमिट्स 1 ऊपर चली जाएंगी बिकॉज द फंक्शन इज स्टार्टिंग फ्रॉम 1.
Right.
So I guess that's time invariance.
Time invariance, excellent. But time invariance से सिर्फ लिमिट शिफ्ट नहीं होती, पूरा का पूरा सिग्नल शिफ्ट होता है.
Yes, sir.
Right. So here's the point. Here's the explanation. Right. I know from this. So if x of t is an input to an LTI system which has an impulse response equal to u of t, right, and that results in output y1 of t. I know from commutativity that this is equal to the saying कि x of u of t अगर input थी LTI system की और उसका impulse response x of t था, then my output would be y1 of t, right? But if my input is u of t minus 1, since the system is LTI, and if it had the same impulse response x of t, my output should have been equal to y1 t minus 1. So if an input shift in the input by 1 second should cause the same shift in the output as well, because the system is time invariant. Okay? From here, therefore, I can conclude, and therefore this is nothing but y2. Right? So y2 of t, therefore, must be, oops. So this implies that y2 of t must be equal to y1 of t minus 1. So y2 should only be a shifted version of y1. And that's enough for me to now compute the overall convolution, right? So remember, y1 of t was of this form. Let me write this again, which is 0 for t is less than 0, which is t squared by 2 0 is less than t is less than 2, and 2 for t is greater than 2, right? If I were to sketch this out, what would the sketch be? This would be 0 here, and then a squared increase, and then the flattening off at time t equals 2. Okay? And y2 of t would just simply be equal to y1 of t minus 1. And वो क्या होगा? वो क्या दिखेगा? This would just simply be a shifted version of that. And so this would be here, and this would be here, and at this would be time t equals 3. Okay? And then you just need to subtract one from the other. And let me just give you the final answer. So y of t equals y1 of t minus y2 of t. So this is a piecewise function which is equal to 0 for t is less than 0. Okay? Pair is equal to t squared by 2 for 1 is less than t is less than 1, and is equal to t squared by 2 minus t minus 1 whole squared by 2 for sorry, this is 0 and 1. 1 is less than t is less than 2, and this would be, so take my word for this now, 2 is less than t is less than 3, and it's going to be 0 for all t is greater than 3. Okay? And you can go about doing the convolution other ways if you want to, and you will find, if you try to verify, you get the same answer. Okay? So this is where I'm going to stop. Any questions about what we've done? Right, so this wraps up our discussion on continuous time LTI systems. And this is, I think, chapter 2 of the textbook. So next time around, we will most likely start with chapter 3 of the textbook, which is 4-year series. Questions? G. Hamza.
Ji sir, will we be doing discrete time signals anytime soon before the 4-year series, या फिर हम लोग अभी सिर्फ continuous time को ही देखेंगे?
So my inclination is to stick with continuous time for now, and then we're going to come to discrete time, perhaps towards the latter part of the course, and then we're just going to stick with discrete time. आखिर में.
ठीक हो गया sir, thank you.
Right. So that's something we're doing differently this year.